This is discrete 45, I believe. So let's go ahead and get started. All right, it says consider the fully protonated amino acid shown. As the pH of the solution of the amino acid is raised, which group deprotonates first? So basically what this is asking is which one of these is the most acidic? We can immediately rule out 2. With the answer choices, that's going to be 2 and 4. Why is that? Well, these are carboxylic acids, literally acids, right? These are going to be the ones that deprotonate first, aka these are the most acidic, right? You're releasing that hydrogen. Hydrogen is what measures acidity. So yes, these are the carboxylic acids. These are the ones that are going to deprotonate first because they are acids, okay? Acids deprotonate easily. So that means 2 and 4 cannot be the correct answer. So between these two answer choices, right, 1 and 3, which of these is going to be more acidic? And the answer is 1. Why is that? You have these chlorines right here. You actually have 2 chlorines. And due to the inductive effect, basically what that means is it's going to be easier for this carboxylic acid to release and lose that hydrogen, making it more acidic. The inductive effect isn't nearly as strong with the protonated amine on the side here, meaning 1 is going to be the correct answer. I believe they say the pK for this is around 10 or something along those lines. I'm not exactly sure, but essentially the inductive effect by the 2 chlorine atoms is enough to lower the pKa of this this carboxylic acid by a significant amount. Okay, so let's look at this next discrete here. It says the graph represents the energy change in an exothermic reaction. Which of the following expressions gives the activation energy for this reaction? So this is a discrete. You just have to know that the activation energy is from the baseline, right, of the reactants up to the top of the transition point energy. And what does that mean? To measure this energy, it's just going to be the energy at E3 minus the energy at E2. That gives you activation energy, which means the answer choice is C. All right, so let's take a look at this next question. It says a 2 kilogram mass and a 5 kilogram mass are connected by a massless cord suspended over a massless and frictionless pulley. If the acceleration due to gravity is g, what will be the acceleration of the masses after they are released from rest? So what does that mean? Let's take a look at what this means. Let's draw a diagram. All right, so we have the pulley here. We have a 5 kilogram mass here, and we have a 2 kilogram mass here. All right, so it's basically asking, hey, what's the acceleration going to be? And I'm going to do this in the most formal way that I know, and it's going to be to draw a system of equations. So anytime you have pulleys, it's always going to be a system of equations where you look and focus on one side of the pulley at a time. So let's split this down the middle. Okay, let's focus on the 5 kilogram side first. So just by intuition, we know the 5 kilogram side is going to be the one that falls down, and the 2 kilogram side is going to be the one that comes up. And so what does that mean? Well, let's look at what forces are acting on the 5 kilogram block. You have the force of gravity, and then you have the force of tension from the rope that's pulling it up. So what does that mean? The force of gravity is going to be 5g, right? So force of gravity is equal to mg, where m we know is 5 kilograms. And we know that the force of tension is, let's just say that's going to be Ft, so force of tension. And that's going to equal the acceleration of this block. That's going to be equal to the total net force. And remember, net force is equal to mass times acceleration, where we know the mass is 5, and we don't know exactly what the acceleration is, but let's say the acceleration is a, and we'll label this as a1, okay? Now, on the 2 kilogram block side, let me backtrack here a little bit. On the left side, I put 5g minus ft because we know that the 5g, the force of gravity pulling down, is going to be stronger than the force of the tension on the pulley string. How do I know that? Because I know this side's going to be coming down. So if I wanted to make this a positive expression, I put 5g minus ft, since 5g we know has to be greater than ft. So on the opposite side, it's actually the opposite. Because we know this block is going up, we know the force tension of the rope that's pulling that block up has to be greater than the gravitational force acting on the block. So what does that mean? The force of tension is going to be greater than 2g, so I'm going to put it first. All right, so this is the right side of the pulley. And why did I put force of tension here? Remember, when we're working with a pulley, the force of tension, the tension force on this string is always going to be the same no matter where you are on the pulley. So I know this force of tension has to equal this force of tension. And that's equal to the mass times acceleration again. So this mass this time is 2, and the acceleration this time is, let's say it's 2. All right, so these are our two equations here, and we're going to try to solve for acceleration of the blocks. Now, what do we know about the acceleration of these blocks? We know that because they're connected by a string, the acceleration has to be the same. So what does that mean? A1 has to equal A2. So instead of A1 or 2, let's just get rid of these and both say they're just accelerations. So what do we get from here? What do we get? We get a way to solve this system of equations. So what if we added these two equations up? We get 5g plus ft minus Ft minus 2g is equal to 5a plus 2a. What does that mean? Well, the Ft's cancel out. This becomes 3g is equal to 7a. Solve for acceleration. A is equal to 3g over 7. All right, so that's how you solve these pulley questions. Remember, split it into two different sides. Focus on each side. Okay. Keep track of the signs of the force of tensions and the gravitational force. And once you have that, you can solve the system of equations from there. So the answer here will be B. All right, let's take a look at this question. An ice cube at 0 degrees Celsius and 1 atm is heated to form steam at 100 degrees Celsius and 1 atm. Ignoring heat loss to the surroundings, what part of the process uses the most heat? So what do we have? We have ice, and it's going to melt. So we have ice to water, and it's going to heat up, and it's going to become steam. So what does this look like on a graph? So we have ice, and we are going to transition it into water. And then from water, it's going to increase in temperature until it reaches the boiling point and it becomes steam, okay? So what does this mean? So we have heat and then basically a phase change / temperature. Or actually, I guess the y-axis here would just be only temperature. Ooh, there we go. All right. So when it's, when the ice is becoming water, what do we use? We use heat of fusion. So let's say we have 1 gram. So that means of this ice. So when this ice is becoming water, it's going to take 80 calories for the entire thing to become water. So that means, let's say we used 80 calories for that part. Now, when it's increasing in temperature from water from 0 degrees Celsius to 100 degrees Celsius, it tells us that 1 calorie is needed for every gram and every degree Celsius you're trying to increase. So if you're going from 0 degrees to 100 degrees, you're increasing the temperature of the water by 100 degrees Celsius. And like I said again, we only have 1 gram of water. So if we multiply this out by 100 and 1, so if it's 1 cal per gram degrees Celsius times 100 degrees Celsius times 1 gram, right? That's going to yield 100 calories. All right, so this part here, 100 calories. And then heat of vaporization, okay? So this is when you now convert all of that water at 100 degrees Celsius back into, well, essentially it's boiling, and now how much is it going to take? How much energy is it going to take from the water point, the water at 100 degrees Celsius to steam at 100 degrees Celsius? And that's 540 calories per gram. So if we have 1 gram, that tells us that this process requires us to use 540 calories. So what point do we right? What point of this process uses the most amount of heat? Well, that's going to be the one that requires 540 calories, right? And that's going to be D, when you're vaporizing all the water. So this is when you were melting the ice cube. This is when you were heating the water from 0 degrees Celsius to 100 degrees Celsius. And this is when you get the water up to, no change in temperature, but making all the water into steam. The liquid water into steam, sorry.